Imagine looking up at the night sky and seeing the moon shatter brilliant fragments scattering like a broken lantern. In the first 10 seconds, your mind screams, could pieces fall to Earth? This is the hook. If the moon broke into pieces, our world would not just lose a pretty face. Everything would change. First, let's set the scene. The moon is 3,474 kilometers across and orbits about 384,000 kilometers away. It's held together by its own gravity and by the slow dance it has shared with Earth for 4.5 billion years. To break the moon, you'd need an enormous energy, a massive impact or tidal forces strong enough to overcome its gravity. Depending on how it broke, the pieces could behave very differently. Some would fall, some would escape, and some might form rings. If a huge asteroid slammed into the moon, chunks would spray outward at high speed, throwing up dust and rock. Some fragments would be slowed by lunar gravity and fall back, deepening craters and sending plumes into space. Other fragments with enough velocity could enter new orbits around Earth, becoming temporary moons or a dangerous swarm. The smallest debris would vaporize into dust, creating a diffuse cloud that could dim or redden moonlight for months or years. Larger chunks that cross Earth's path would become incoming meteoroids, some tiny flashes, others catastrophic impacts. Even relatively modest lunar fragments striking Earth would release energy many times larger than typical meteorite strikes. Beaches, cities, forests, anything in the direct path of a big fragment would face devastating local effects. But worst of all, many pieces could break into thousands of smaller projectiles, creating a prolonged rain of impacts. The global danger depends on how much mass ends up on Earth-crossing trajectories versus stuck around Earth. If enough material stayed in orbit, it could spread into a ring system, like what we see around Saturn, casting strange shadows at dusk. A ring would change night brightness. Some nights the sky could glow faintly, others be darker if dust blocks starlight. Tides would shift dramatically. The moon is the main driver of our ocean tides, and fragments would tug unpredictably. Initially, chaotic gravitational pulls would generate unusual tides, massive sloshing, and likely global tsunamis along many coastlines. Over years, as fragments settle into stable orbits or fall away, tidal patterns would either weaken or reorganize under a new gravitational balance. The moon also stabilizes Earth's axial tilt. Without its steadying mass, our tilt could wobble more over long time scales. That wobble would mean more extreme climate swings across centuries and millennia. Hotter summers, colder winters in some regions. The immediate human problems are simpler and cruel. Satellite damage from debris, disruption of GPS and communications, and a sky filled with fireballs. Economies, agriculture, and coastal communities would be hit hard by unpredictable weather, damaged infrastructure, and loss of seafood from altered tides. But there's another, quieter consequence. Nights would change forever, eclipses, moonlit rituals, and the subtle rhythm of life tied to lunar cycles. In a more hopeful scenario, scientists might study the debris and learn about the moon's interior like never before. The twist is this: the moon could partially reaccrete. Gravity can glue some chunks back together into a smaller moon over long times. Or Earth might gain a ring for thousands to millions of years, a new jewel in the sky that changes how we think about night. Emotionally, losing the familiar full moon would feel like losing a part of our cultural memory. Myths, calendars, and lullabies all altered. Practically, humanity could adapt. Better early warning systems for impacts, hardened satellites, and coastal planning for tidal chaos. The worst moments would be brutal and fast, but the slow aftermath would reshape life, science, and how we navigate our future. So when you look up tonight, remember, the moon's quiet presence is one of Earth's great stabilizers, and its loss would be both violent and transformative. If you want more mind-bending what-ifs and careful science mixed with dramatic storytelling, like this video and subscribe for the next one.